We're going to look at exponential learning target 2B. We're first going to look at a linear graph compared to an exponential function graph. A linear graph will always look like a straight line, where my exponential graph will have a curve. A linear graph looks like a straight line because we're adding or subtracting by the same number, where exponential function graph will always be curved because we are multiplying or dividing by the same number. Now we're going to look at 4 different scenarios. Remember y equals a times b to the x, where my a is my y-intercept and my b is my common ratio. In order for our graph to be growth, my common ratio needs to be greater than or equal to 1. So let's go ahead and look at if my y-intercept, my a is positive. So I'm going to go ahead and plot positive 2 on my graph. And then since I know that my common ratio is greater than or equal to 1, I'm going to come in from the left, hit my dot, and then it increases. Now, if my y-intercept was negative, let's say negative 2, same thing, I'm still coming in from the left, hitting my dot, and then decreasing. Now for decay, this is when my b is between 0 and 1. So let's look at this being a positive y-intercept. Let's say positive 3. For decay, I come in from the right side, hit my dot, and then goes up. With a negative y-intercept, let's plot negative 3. Oops. I still come in from the right, hit my point, and then it decreases. These are all the 4 possibilities that you will be used for graphing exponential functions.